Hi guys.
Hello. Hey, hi.
Hey Abdul. Hey Sridhar. Hi guys. Good evening.
Hi, bro.
Hi. Okay, let's just wait for 2 more minutes for the others to join as well, and we'll start the session.
Okay.
Sure. Thank you.
As discussed earlier in the last session, today we'll be going with the first topic of cybersecurity, which is a prerequisite networking fundamentals, understanding what IP addresses are, what are the different categories of IP addresses, and some important networking protocols. Okay, as we progress. So again, just in case if you have not joined the session yesterday and if this is your first class today, nothing to worry, guys. These classes are being recorded and they're being uploaded as they go on YouTube on the official channel of DurgaSoft itself. So you can access the previous sessions there. And I think we have only taken up one session earlier, the yesterday's session, and it's a demo session. I basically explained what topics were going to be covered in the upcoming sessions and what other tools we'll be using and the entire course curriculum. So just in case if you have not joined the session yesterday, you can access it there. Okay. And today we will be going through the first topic, networking fundamentals. Okay, guys, let's get started without any further ado, without waiting for the other students. I think they're not available, the ones who joined yesterday. Okay. So before we begin with networking, a brief introduction on my, since they're new students today. My name is Mohammed Shoaib. I will be your cybersecurity trainer for the, again, entire duration of the course. I've had an experience of more than 7+ years in this domain, and I've been working currently as a cybersecurity SOC analyst, I would say, level 2. Okay. Again, I work on tools like Splunk and IBM QRadar and Splunk add-ons like Security Essentials. Okay. And again, this course, Certified Ethical Hacking version 13, is one of the fundamental courses taken up by students who want to get into the domain of cybersecurity in the first place. Okay. And again, I do train some other advanced courses as well. But for people who are just getting with cybersecurity or trying to shift their careers into cybersecurity, this is the course that is taken up first. Okay. Now, again, as mentioned, we'll talk about networking fundamentals now. Whenever we talk about networking, guys, there are three important definitions to know. What is networking in the first place? What are networks and what are hosts? When you talk about networking, this is the practice of connecting information devices with each other. Okay. So when you call a network, basically a network comprises of multiple devices and the process of connecting those devices with each other so that they can transmit data or resources or share resources is called as networking. So having an organization, and in that organization having your computers, your servers, your routers, your printers, your IP cameras, your firewalls, etc., all interconnected and communicating with each other. So that process of having that communication established is called networking. Okay. And each of those devices in that network or in that group of collection of those devices is called as a host. Okay. So network comprises of the devices collectively together. The interconnected devices comprises of various devices in it. Okay. And each of those devices is called as a host. Okay. Now, when we humans communicate with each other, we call each other or we address each other with our names, our respective names. So I can call you Sridhar, Abdul, etc., and you would call me back by my name. Similarly, these hosts or these devices also have their unique names to them. Okay, and that unique identity is basically your IP address, Internet Protocol address. Okay, so no matter what device you take, whether it be a computer, a printer, a router, a mobile phone, again your Bluetooth speakers, your smartwatch, your again IP cameras, etc., etc. No matter what device you take, each of these devices is called as a host, and that host requires a identification. That unique identifier for each of the hosts on the network is called as an IP address. Okay, and these IP addresses allow for communication to occur between these hosts. So when one device wants to call up the other device or speak to the other device, they would have to initiate the communication on these IP addresses itself. And these were invented, I would say, by the US military in the late 1950s or so. And just 1 second, please. Give me 1 minute. I think someone's trying to join the session. Is the session being restricted? Oh, okay, never mind. So again, as mentioned, these IP addresses were invented by the US military, and I think they were done so in 1950s or so, 1950s or 1960s. Okay, and there were multiple versions of it. There was IP version 1, IP version 2, IP version 3, etc., etc. They were quite experimental. Okay, what successfully worked out was IP version 4, Internet Protocol version 4. Okay, and we are still using that IPv4 addresses, Internet Protocol version 4 addresses, even in today's world. Okay, now when you talk about these IPv4 addresses, these addresses have a few properties to them. Let's talk about that. Okay, so firstly, this IPv4 address or Internet Protocol version 4 address has 32 bits in it. What I mean by 32-bit address is it contains 32 zeros or ones. So a bit is the smallest data value a computer can hold or can understand. And that value can either comprise of 0 or with the value of 1. Okay. And your IPv4 address is a compilation, I would say, of 32 zeros and ones. Okay. And that entire 32-bit address again is not as it is. It is broken down in 4 equal parts, where each of these parts is called as an octet, and it contains 8 bits in it. Okay, so each of that 8-bit portion is called as an octet. And these octets together, 4 octets together, forms your IPv4 address. Okay, and each of these octets is separated by a dot symbol. So this is what your typical IPv4 address would look like in the language of zeros and ones. So you have 8 bits here, then a dot, then another 8 bits here, then a dot, then another 8 bits here, then a dot, and then another 8 bits here. Okay, a total of 32 bits in itself. Okay. And what you see here is very commonly known as binary language, the language of zeros and ones. Okay. The reason why it's called binary is because there are only two characters in it, either the 0 or the character 1. Okay. And computers very easily understand binary language, but we humans can't do so. Okay. It's a bit tough to understand binary as soon as you look at it. Okay. What we regularly understand or what we regularly use decimal numbers, okay, numbers from 0 to 9. Okay, and now I'll be showing you how do you convert any binary address into a human readable decimal address. Okay, so this number here, 11000000, first octet, can actually be converted to 192. This number 10101000 is actually equal to 168. This number, all zeros here, is simply 0. And this number 00001010 is actually equal to 10. So now we'll be learning how can you convert this. It's a very simple trick, a very simple procedure. And once you understand this, you would be able to communicate or convert any binary number in this world into a decimal number on your own. Okay. A very simple and a neat trick, I would say. Okay. Before that, any questions or doubts up to this point? Anyone? Abdul, Sridhar.
No, we are good. Shoaib.
Okay, perfect. Now, when you talk about this conversion, guys, there's a simple trick to it. So I've taken up a binary number here, an octet, I would say, of 10101010. So this is the number I would like to convert. And in order to do so, the first step you would take is you write down the values of 2 power 0 all the way up to 2 power 7. So under the rightmost bit, you have 2 power 0, then there's 2 power 1, then 2 power 2, then 2 power 3, then 2 power 4, then 2 power 5, then 2 power 6, and then 2 power 7. So from right to left, under each bit, you have written down the values as such. Now, if you have a question why specifically 2 power, this is a binary address. You only have two possibilities, hence 2 power everything. Okay. Once those values are written down, then you multiply the lower value with the top bit. So 2 power 0 into 0 plus, then you add it with the next one, plus 2 power 1 into 1 plus 2 power 2 into 0 plus 2 power 3 into 1 plus 2 power 4 into 0 plus 2 power 5 into 1 plus 2 power 6 into 0 plus 2 power 7 into 1. So you're multiplying the lower value with the top bit and you're adding it till the end. Okay. Now let's try converting these values, guys. So again, firstly, let me give you the table here for these values. Anything to the power 0 is always equal to 1. It's a mathematical rule. So 2 power 0 is also equal to 1. So 2 power 1 is 2 itself. 2 power 2 is 4. 2 power 3 is 8. 2 power 4 is 16. 2 power 5 is 32. 2 power 6 is 64. And 2 power 7 is 128. So you have to remember these values, guys, in order to perform the conversion. Okay, because now you would just substitute those values here. So 2 power 0 into 0. 2 power 0 is 1. So 1 into 0, that's simply 0. Okay. Then plus 2 power 1 into 1. 2 power 1 is 2. So 2 into 1, that's 2. 2 power 2 into 0, that's 0 again. 2 power 3 into 1, that's 8. 2 power 4 into 0, 0 again. 2 power 5 into 1, 32. 2 power 6 into 0, 0 again. And 2 power 7 into 1, 128. And if you add all this up, 128 plus 32, that's 160. 160 plus 8, 168. 168 plus 2, 170. So when we humans read the number 170 as 170, the computer reads it as 10101010. Something like high frequency, low frequency, high, low, high, low, high, low. So when that exact pattern of frequencies flows through a computer, it understands it as the number 170. Okay. So that is how you convert any binary number to a human readable decimal number, guys. I hope it's clear. I hope it's very simple and straightforward. Any questions or doubts up to this point?
No.
Yeah. Abdul, did you join through two accounts or is this two different people?
No, sure. I joined
All right.
with the laptop, but my laptop audio was not working. So I have joined with my mobile for that.
Oh, so it's the same person, right? Okay.
Yeah, I am the same person.
Oh, done. Perfect. So now I hope you're still I hope you're able to hear me now though from the phone at least.
Yeah. I can be able to hear.
Perfect, perfect, perfect. Right. Okay. So if you have understood this, guys, I have some other examples as well. What I want you to do now is if you have a pen and a paper beside you, calculate the answers for these numbers 0 1 0 1 0 1 0 1 and all ones. So same logic again. Multiply the lower bit with the top one and keep on adding it and give me the answers for these two numbers. First example is 0 1 0 1 0 1 0 1. Second example is all ones in all the 8 bits. Take your time, guys, no rush. If you have a pen and a paper beside you. can calculate and give me the answers.
So first one is kind of 87. So example one is
87. Okay, let's check it out in a while. Second one, Sridhar.
yeah, second one is checking.
Okay, no problem. Take your time. No rush.
Hello, hi Shoaib.
Oh, Abdul, you were saying something.
Yeah, Shoaib, actually I did not get the examples like when you was explaining, my audio was not working. So you can help me for this one because
No worries, no
I'm
worries, Abdul. I'll explain the examples this time for these two. Nothing to
getting.
worry.
Second one is 255. First one is 87.
87. Okay. Okay, guys. Very close answer for the first one, Sridhar. It is 85, I suppose, if I remember correctly. But yeah, let's calculate it. So 2 power 0 into 1. So again, no matter what binary octet you take here, you would just write down the values from 2 power 0 to 2 power 7 from right to left. Why specifically 2 power? Because it's a binary number, two values only. Yeah. And then you multiply the lower value with the top bit. Okay, so 2 power 0 into 1 plus 2 power 1 into 0 plus 2 power 2 into 1 plus 2 power 3 into 0. That way, all the way up to 2 power 7 into. Put the value there. Okay. And I've written down the values for these here. 2 power 0 into 1. 2 power 0 is 1. So 1 into 1, that's 1. Okay. And then 2 power 1 into 0, that's 0. 2 power 2 into 1, that's 4. 2 power 3 into 0 is 0. 2 power 4 into 1, 16. 2 power 5 into 0, 0. 2 power 6 into 1, 64. And 2 power 7 into 0, 0. Okay. So now if you keep adding it up, 64 plus 16, that's 80. 80 plus 4, 84. 84 plus 1, 85. Okay.
Yeah.
I think a minor miscalculation somewhere, right?
So might be added 2 power 1. 2 power 1, I think I added as a 2, I think. So
Probably. Yeah, could be. Okay. And again, second answer is perfectly right, Sridhar. So you have all ones everywhere. So you add everything up. 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. And if you add all that up, you get 55 as the answer. So perfect answer for that. Okay. Now, I hope it is clear now, Abdul, if not earlier.
Yes, yes, sure.
Perfect. I hope you're not hesitating. Please do let me know, Abdul. If it's still not clear, I'll explain again. Okay. Don't hesitate. You can ask me as many times as you want. That's totally okay. Okay. It's my responsibility to see to it that you understand these things because these fundamentals are quite important as we progress with our classes. Okay. So do not hesitate. You're paying for this. So take full advantage of it. Okay.
Yes.
So, right. Moving on. The reason I'm explaining you all this is because you need to understand the range of IP addresses, guys. So now, if I had to get the range of IPs, the first IP and the last IP, all I have to do is simply put zeros everywhere for the first IP and ones everywhere for the last IP because that's the minimum value and this is the maximum value. So when I put all zeros everywhere, I get the first IP as 0.0.0.0 simply. Okay, because you have zeros everywhere. And if I put all ones, you just calculated the answer. For all ones, we get 255. So the last IP would be 255.255.255.255. Okay, here's the first IP and here's the last IP. From this, we can understand that no matter what IPv4 address you take, it will never exceed the number 255. So all the IPs that exist between octets of zeros and 255s itself. They cannot be in negatives and neither can they be beyond the number 255. Why? Because when you put all ones in the octet, the maximum you can get is 255 itself, not more than that. Okay. And if you had to calculate how many IPs you have in total, each octet has two possibilities here. So you can 0 or 1, 0 or 1, 0 or 1. So two possibilities 32 times. So 2 into 2 into 2 into 2, 32 times that way. So that would be 2 raised to the power of 32. And that would be 4.3 billion IP addresses. So when these IPs were invented in the 1950s or so, 4.3 billion was a very large number back then because you didn't have mobile phones, you didn't have multinational companies or etc. etc. Hardly people had access to internet. Okay, but fast forward to 2025, this year, again, there are 8 billion people, I would say, more than 8 billion actually, and each person again could have multiple devices. So 4.3 billion IPs assigned individually would never have been sufficient. So these IPs, that's why, are categorized again. So there are multiple categories in them. Okay, but before we get into the category part, let's talk about the sequence of IPs. Any questions or doubts?
No.
Abdul, any questions on your?
No, sure. Actually, I want to know like how we are calculating for getting this one for the IP. I'm not getting that.
Which one? Which one? Sorry, excuse me.
Like in the previous one, we have calculate for getting the 255, right?
Uh-huh. Yeah.
So means I want to know like how we
For
calculate for that one, and this the
250.
IP.
Oh, okay, nothing to worry. Let me explain it one more time. So again, as mentioned, whenever you want to convert any binary number to a human readable decimal number. So if this is the octet here, let's say, okay, octet is nothing but 8 bits of data. Okay. So if you have an octet like 10101010, step number one,
Yeah.
excuse me, a bit of a cold.
Yeah.
So
Yes. Yes.
step number one is you would assign all the values from 2 power 0 to 2 power 7 under each bit. Once those values are assigned, you just multiply the lower value with the top bit. 2 power 0 into 0 plus 2 power 1 into 1 plus 2 power 2 into 0 plus 2 power 3 into 1 plus 2 power 4 into 0 plus 2 power 5 into 1 plus 2 power 6 into 0 plus 2 power 7 into 1. So you have these
Then we
values.
need.
You just substitute those values there and multiply and add. Okay. Now, if I had to get the first IP, how do I get that? I just put all zeros everywhere. Okay, because that is the minimum value I can get. So when I put all zeros everywhere, it would be 2 power 0 into 0, 2 power 1 into 0, 2 power 2 into 0, 2 power 3 into 0, everything into 0. That's why you get the first IP 0, 0, 0, 0.
Zero. Yes,
Right?
I got.
If I had to
Yes.
get the last IP, I put all ones, the other alternative. Maximum value can be obtained when I put all ones. And when I put
So
all
it
ones,
step
it would
down.
be 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. And if you add all that up, you get 255. That's why you have 255 here. 255.255.255.255. So for each octet here filled with
Right.
ones, I'm putting 255 there. Is that clear?
Okay.
Right. And if I had to get the total number of IPs, again, you can notice each bit here has two possibilities, 0 or 1. And there are 32 bits as such. So 2 into 2 into 2 into 2 into 2 into 2 into 2, like that 32 times. And that would give
Oh,
you 2 to the power 32. That is 4.3 billion IP addresses. Okay. Is that clear
oh yeah. Okay, sure.
now? Apologies, guys. I have a bit of a cold today. So yeah, now let's talk about the sequence of IPs. So we know the first IP, we know the last IP. What about the IPs in between? How are they progressing one after the other? So to understand that sequence, there are two simple rules again. Okay, everything has two rules. So again, if I go to a simple document here to explain, so now we all know the first IP is always 0000. Okay. Now, if I had to get the next IP, rule number one is you just increment from the rightmost octet. Okay. So the rightmost octet increases by one. So after 0000, you have 0001, then 02, then 03. So the rightmost octet is increasing by the value of one. Okay. So 03, 04, 05, 06, 07, 08, 09, 010, 011, 012 goes on all the way up to 0255. Now, once it reaches the maximum value there, once the rightmost octet reaches the maximum value, then you move to the left octet. So that 255 cycles back to zero. Okay. So it resets back to zero. And then the left octet changes by one. Okay. So after 0255, you have 10. Now, after 10, don't directly jump to 0020. That would be wrong again. Remember rule number one, always increment from the rightmost octet. So after 10, you have 11, then 12, then 13, then 14, 15, 16, 17, 18, 19, 110, 111, 112 goes up to 1255. Okay. Then you have 20. So this 255 cycles back to zero again. And this one now increments by one. You get two. So you see there's a pattern here. 00 to 0255, 10 to 1255, 20 to 2255, 30 to 3255, 40 to 4255, 50 to 5255. Like that, the cycle keeps on repeating. And down the line, you would have 2540 to 254255, 2550 to 255255. Now, once both these octets are filled, same logic, they cycle back to zeros, and the next zero changes to one. Okay, so you have 100. Okay, if you notice now, you have the same 00 again, like we had in the first. Okay, so that 00 again goes to 0255, 10 to 1255, 20 to 2255, 30 to 3255. So when it reaches 255, 255 again, this one now changes to 2. Okay, so this is another pattern. 000 to 0255 100 to 1255 200 to 2255 300 to 3255 400 to 4255 Like that, the pattern keeps on repeating. And somewhere down the line, you would have 25500 to 255. Once all these three octets are filled, this zero finally changes to 1. So whatever cycle repeated here up to 0255 from the first IP, same thing repeats again from 1000 to 1255. Okay. Then 2000 to 2255 3000 to 3255 4000 to 4255. And like that, finally, you have 255000 to 255. Here's the last IP. Here's the first IP, and here's the last IP. Definitely, I skipped a lot of IPs in between, but if you count each and every IP individually, you'd get a total of 4.3 billion IPs that way. Okay. So that is the entire sequence of IPs, I would say. Excuse me. Apologies about that. Terrible code. Right. So I hope you've understood the sequence, guys, how the IPs are progressing one after the other from 0000 to 255, 255, 255, 255. Any questions, any doubts?
No, we are good.
Okay.
Yeah,
Yeah, Abdul, you were saying?
yeah. Like, can you explain from this one? Like, I did not get this one again. From the sequence of 00 to, if there are three zeros,
If there are three zeros,
if there are three zeros, how we will get the fourth one, like 00.4?
where are you talking? 1 second.
Yeah, from the starting.
Yeah, you have four zeros here. As
Yeah.
mentioned, you just keep incrementing the rightmost octet. So 0000.
One shift increment in all this is 0.1.
1 second. Okay, in here, where are you referring? Just let me know where to stop the mouse. I'm going through the sequence.
This sequence, how it goes? It goes like 0, 0001, 0002. It goes
Yeah,
like this.
exactly that way. So from bottom to top. 1 second, let me draw it out. So it goes like this, bottom to top, and then like this.
If okay.
That's how the sequence is going. Okay. So again, as mentioned, there are rules for that sequence as well. Okay. So if I had to show it again, so first you have 0000. Always increment from the rightmost octet. 0001,
Okay.
2, 3, 4, 5, 6, 7, 8 goes up to 255. Okay. Then after it
Okay.
reaches 255, you cannot have a value like 00 to 0256. That is not possible. Okay.
Okay.
So once it reaches 255, then that 255 goes back to 0. And the next one changes to 1. So you have 1, 0. Then 1, 1,
Okay.
1,
The
2, 3,
previous one
4.
will change into 1.
Yeah, the one leftward increases by 1 because the
1.
rightmost is filled. Okay. So it's very similar to your, if I had to give you a very simple example, it's like your speedometer for your vehicle. So in the olden days, we would have a meter. Today we have all digitals, but in the olden days, you would have meters like this. Okay. So after
Yeah.
four zeros, let's say, then you have 0001, 0002, 0003, 0004. This goes on until 0009. Okay. So assume this 9 is something like 255. So once it reaches the maximum value here, what happens then? This 9 cycles back to 0 and the next one increases by 1. So after 0009, you have 0010. Right.
1 0. Yeah.
Same thing over here as well. After 000255, where is it? Yeah, here,
It becomes 0 0
000255,
1 0.
0010. Then 10 goes up to, then you have 0011, 0012, 0013. This goes on up to 0019. Okay. So that 19 is something like 1.255. And then you have 0020, right? Same thing. So you have 11, 12, 13, 14, 15, 16. Goes up to 1255. Okay. And then you have 20. Okay. Same exact thing over here. Okay. Then 20 goes up to 29. Then you have 0030. Okay. This goes on and on and on. And somewhere down the line, you would have 0099. Okay. Something like 00255, 255. Okay. What happens after 0099? You have 0100. Okay. Something very similar to 0.1.0.0. Okay. Then you have 0101. Oh, sorry, 0101. Okay. Something very similar. 0101. Okay. This goes on up to 0109. Okay. That is something to similar to 01. 0.1.0.255. Okay. So wherever there's 9, just assume it's something like .255. Okay. What comes after 9? 0110. Okay. That is similar to 0, sorry, 0.1.1.0. Okay. Same exact logic, no difference at all. Okay. I hope it is making sense with this example. Sridhar, Abdul.
Yep.
Yes, sir.
Perfect. Okay, so again, the reason I've explained the sequence, guys, is because this is important for us in the upcoming sessions. Because now in the upcoming sessions, we'll talk about these classifications. So that entire 4.3 billion IPs are not in a sequential, I mean, I wouldn't say are used for only in one category. So there are multiple categories in them again. So there are 5 categories called classes: class A, B, C, D, and E. And in those 5 classes, again, there are subcategories: public and private, public and private, public and private. So in the next session, I'm going to explain clearly what these public and private IPs are. Where do you use each of them? So in your home network, what is used? On the internet, what is used? Okay. And then we'll talk about the classes as well. So for each class, there's a certain range. And here in these ranges, we'll use the sequences again. Okay. And I'll explain clearly what's the importance or what's the relevance of these classes. That's an important topic. We'll cover all this in the next session. What is class A? What is class B? What is class C? We'll talk about all this in the next class in tomorrow's session, guys. Is that clear? Any questions up to this point, Abdul, Sridhar? Hi, Rahul. Can you hear me? Hey, Rahul. I think you've joined a bit late today. Excuse me. I have a bit of a cold. Oh, okay. I think Sridhar and Mohammed Abdul, I think you guys don't have any questions, guys. So you can join the session tomorrow at the same time. And we'll be going into much more deeper concepts on networking fundamentals. Okay. And Rahul, if you have missed out the session, nothing to worry. The session will be recorded and it will be uploaded online on the official channel of YouTube. So you can, I mean, on the official channel of DurgaSoft on YouTube. You can access it there. Okay. So we talk about networking fundamentals today. Again, not everything. Again, very basics, very easy to understand. Tomorrow we'll talk about some advanced concepts. What are classes and what are the categories of IPs? Okay. So please do join the session tomorrow, guys. It's an important class as well. And yeah, if you have missed out any classes, access the recordings on YouTube. And these recordings are only available until this Friday. After Friday, the session is going to change to a registered link, and only the registered students will be getting the recordings directly on their email. So if you have not registered already, please do register at the earliest. I think they only have 2 more demo sessions, guys. Okay.
Thank you.
YouTube link. Oh, let me search it very quickly. Again, you can just do a quick search for DurgaSoft cybersecurity. DurgaSoft solutions, cybersecurity. Let's wait for a while, guys. Still loading up. Why is it taking this long? Shouldn't take this long. Yeah,
Sure.
sure.
Can I disconnect now? I mean,
Oh, yeah, sure, guys. You can. Again, you can just search for DurgaSoft Solutions Cybersecurity, filter it by recently uploaded, and you get all the recordings. So this was the recording from yesterday's class, guys. You can access it. Okay. I can just drop that link in the chat box. Right, this is the session yesterday. You can exit today and you can connect back tomorrow, guys. Bye-bye. Have a good day. Thanks for joining the session today, guys. Please do join tomorrow. It's going to be a much more in-depth concept on networking. Bye-bye. Have a good day.
Thank you.